notes. We've already dealt with exponents before a little bit, right? You know what they mean, huh? Yeah, I did that earlier. What does it mean when you have an exponent? It's just like repeated multiplication, right? Okay, and there were some kind of little exponent rules that we worked out at some point, if I remember correctly. So let me just do this. I'm going to set this up a little better before than they do, I think. So let's go to our notes page real quick. Do a quick review. Exponents. Review. All right. So at some point, I believe we talked about a power to a power. Like if I had x squared times x to the fourth. Yeah, well, what does that really mean if we break all those out? Well, but why, right? X times x, right, for the x squared, times, but that's really x to the what, right? So if you multiply, or this is power times a power, sorry, not to a power. Power times a power, that's a different thing.
Power of a power.
Yeah, well, that's the next one, right? What if I had something like, well, let's do it this way. So the rule here would be what? X to the A times x to the B would actually be x to the what? In a general sense. No. I thought you said you added those, didn't you?
X to A, B.
You guys all told me you added these. Now you're telling me to multiply. So what you just said, okay, right, but what you said was, you said x to the 2 times 4. When you say AB, that's multiplying, right? So it'd be x to the A plus B when we multiply powers, right? And I think we looked at one that was kind of like this. How about x to the 5th divided by x to the 3rd? Right, so x to the 5th, of course, would be x over what? Right, and so wouldn't these 3 cancel there, and what are you left with? Equals x squared, right? So if I'm dividing then, what would you say the rule is? So if I say x to the A over x to the B, what would that be? A minus B, yeah. Right? Okay. We did the division one before, I'm pretty sure, right? Now let's do the power to a power. Okay? So let's say I have x squared like this, and then cubed out here. So power to a power, right? Well, wouldn't that just be x squared times x squared times x squared? Right? And then by the rule we just did, this would be x to the what? Huh? 6, yeah. X to the 6th power, right? For power to a power. Yeah. So what would be a rule then? If I have x to the A to the B power, that's the one you guys were trying to say earlier, that would be x to the what? A times B. Now it's AB, right? Okay. So power to a power. All right. Hopefully that's mostly review. We did that a little while back. Okay. All right, let's go back to what they got going there. Got it?
Okay, how does that part of the time make sense?
What do you mean?
Adding them together when you multiply them? Oh, because they're all multiplying them together. I was like, dumb. Never mind, never mind, never mind.
Never mind. All right, back here. So let's look at some examples here. So this should be pretty simple to start out. Represent 6 to the third as extended product, like we just did. That would actually be what? Just that, right? That's easy enough, okay? And there's a typo here. See where it says 2x to the squared here, guys? That 2 should be a 3. So it's 2x cubed, 2x to the third. Okay? So f of x is 2x to the third plus 7. Let's find f of negative 1. If I cube a negative, do I get a positive?
Yeah.
Well, hold on. Think about why you get a positive when you square a negative.
Because it's just multiplying.
A negative times a negative, right?
And that equals a positive.
But what about cubing a negative?
No.
It's a negative times a negative
Times a negative.
so it would stay negative, wouldn't it? Okay. So f of negative 1 is going to be equal to times negative 1 cubed plus 7. Now, please tell me you don't want to do 2 times negative 1 first here.
No. -1.
Negative 1 to the third power would
So
be
that
what,
would be
guys?
-1.
Yeah, so it'd be 2 times, well, negative 1 plus 7. And that's,
-2 plus 7.
which equals 5, okay? Yeah, when you square things, it's always going to be positive. You cube them, it's not going to change the sign. Hey, what about to the fourth power?
I would be back again.
Back again? How about the fifth power?
So negative. So
Negative.
It just keeps going.
There you go, right? So even powers, it would always come out how? Positive. And odd powers, it won't change the sign. Okay. So now they have x to the third times x to the fifth. They want us to write in x to the n power. What's the value of n?
No idea.
Well, what do we just do? That's a power times a power. What do I do with the exponents?
Add them.
So it'd be x to the third times x to the fifth equals x to the 3 plus 5, which is x to the 8th. Okay? Just like I did on that notes page here, right? Okay, now D, we have a power to a power, right? We want to know what is the value of A plus B. That's a weird question. I don't, like, why? That part, but we're just going to expand this out because I want you to see this. So I'm going to take 5x cubed. What's getting cubed here, by the way? Just the x here, right? Just the x. Cubed. And then that whole thing squared. Now what's getting squared? The 5 and the x cubed, right? Okay. So, wouldn't that be 5x cubed times 5x cubed? Right? Well, if I just square whatever that thing is, the thing is 5x cubed. So it'll be 5x cubed times 5x cubed, right?
Yeah.
Okay. Let's just, or we could do it this, there's one way. Yeah, that's one way. But let's do what is 5 squared? 25. X to the third squared would be x to the what? Power to a power. What do you do with them? 6. 3 times 2, right? 3 times 2. Isn't it?
Yeah. But that would be 5 since we have it.
No, you add them when you multiply power times a power. Because think of it this way, right? Think of it this way. This would be 5, well, let me do it. I don't need parentheses. It would equal 5x to the third times 5x to the third, right? And 5 times 5 is 25. X to the third times x to the third. Now you add them because we're multiplying, right? So that's x to the 6th. Make sense? All right, scientific notation. You guys have worked with this before, right? It's a way to write really giant numbers and really tiny small numbers efficiently, right?
There's not enough room.
Huh?
Not enough room for that.
Enough room for what?
To write giant numbers and tiny numbers.
Well, that's why scientists develop scientific notation. Save room. All right, so length of a rectangle is 3 times 10 to the 5th meters, right? So wouldn't that just be a 3 followed by 5 zeros?
Yeah.
Okay? And this would be a 2 followed by 4 zeros, right? What is its area? So this is the length and width. How do you find the area of a rectangle? Multiply length times width, right? So area would be 3 times 10 to the 5th, right? Times 2 times 10. That's not an x, by the way, that's times. Right? That's why we generally don't use the times thing in algebra so much anymore. We want to make it look like an x. Okay.
That's a 5, right? Is that a 3?
5. Yeah, 5. Right? So, what's 3 times 2? 6 times 10 to the what? 9, right? Power times a power. You got to add the exponents, right? It's like up here. Top. Because in scientific notation, they use that time symbol, which is the standard they use. But I want to point out that it can be a little confusing, especially if you're kind of sloppy, right? I mean, it looks like an X. It's not a variable X, okay? Which is why when you get into algebra stuff, you use a dot or parentheses and all that stuff, right? For the most part. Okay, let's try this one here. Let me give you guys a chance to try that on your own. So let's take 3x squared times 2x to the 5th to the 3rd. Okay, we'll give you guys a minute to see if you can work those out.
It's hard.
Let's do the 3x squared.
Do that.
Guys, let's do the first one here. It'll be 3 squared times x squared, right? Which would be x to the what?
What?
What is x squared? X to the
You square something more.
x. You multiply it. X to the 4th times what? What's 2 to the 3rd power? Use your fingers. 2 times 2 is what?
4.
Times 2.
8.
Okay. 8x. Well, let me just write it because I do the other one. I'll write it as
Right like that.
2 cubed. 2 cubed x to the what? What? Power to a power. What do I do with those exponents?
I don't know.
Multiplying. Of course you know because I just told you. Look at the notes I gave you on the notes page. Power to a power. So 3 squared is what? 9x to the 4th times what? 8x to the 15th? Okay. What's 9 times 8? 72.
You were right there.
X to the what? 19th. You add those.
That is very, very hard.
No.
Yes.
You're just using the rules that we just talked about, right?
Look at this.
You wrote down the notes I gave you, right?
No.
So power times a power,
I thought you were.
power times a power, you add the exponents. Power to a power, you multiply the exponents. So we had a little of both a couple times in there, right?
No, like it looks like 3x. How did you get 3 squared?
Because I'm squaring the 3 and the x squared.
But that's one thing.
Right, but they get squared, both of them have to get squared. You're right.
It's like simplifying. That's
It's like Well, it was like this one here, wasn't it? Look up here. We squared the 5, and then we squared the x cubed. We just did the same here. But then when we got done, we had more combining to do. All right.
Let's get up.
Nope. Okay, now we have 2x to the 6 divided by 4x squared. When we divide powers, what do we do with the exponents?
Subtract them.
Okay, I don't really like the way I'm going to cross that out. So let's just simplify it. So let's take our 2x to the 6 over 4x squared. Okay, so 2 over 4, first of all, that reduces to what?
1/2. 1/2.
1/2. So just over 2. We don't need the 1 up there. 2. Okay. And then x to the 6 over x squared would be x to the what? 6 minus 2, right? Because you're dividing, you subtract the exponents. Right? Because remember, x to the 6 is x times x times x, right? And x squared is x times x, and 2 of them cancel, right?
Why do we always have to use x?
What's
Well,
it?
that's what they say.
So this would be x to the 4th over 2. That's a 4.
Oh, okay. All under A. Oh.
Yeah. All right, x to the 4th over 2. We divide exponents, divide powers, you subtract the exponents. All right? Let's go over on the next page. Yeah, there's only 2. This part, no, I don't want to do with that. So we're just going to start with, write it as we're just going to simplify these. So this would be, what do we do with these exponents? So it would be 5 to the 7 minus 3, which is what? 5 to the, there you go. Do the other 2. Yeah. So it'll be x to the 4 minus 10, right? Which is x to the negative 6th power. So let me just show you what that actually means. A negative exponent just means the reciprocal of it.
It's going to be positive.
Well, no, that's not the reciprocal. That's actually going to equal 1 over x to the positive 6. So when you have a negative exponent in the top, it comes down to the bottom and it becomes positive. If the negative exponent's on the bottom, goes to the top, it becomes positive. Did anybody get C?
Yeah.
What'd you get?
X to the 4th and y to the negative.
So you had x to the 4th, the words and then.
No, I didn't have and then. I had x 4 y minus y negative 2.
Is 1 over or under?
No. Oh my gosh. No.
Okay.
They're not. No, they're not.
It's actually x to the, what is that? Third over y squared. And we get x to the 3rd over y squared.
Oh, because you have to put a y. I mean, I don't get how you get that. I feel like there should be 5.
So if there's no exponent written,
So what?
it's a 1 right there on that x, right? So this would be x to the 4 minus 1, right?
Oh.
And we separate the bases out, right? Y is a base times y to the 8 minus 10, right?
I'm really lost.
When you divide
Okay, so I got that.
exponents, you subtract, when you divide powers, you subtract the exponents. That's all I did. X to the 4 minus 1, y to the 8 minus 10. So that's x to the 3rd, y to the negative 2, right? Which is actually x to the 3rd over what? Y, now it's positive. Remember? When you move the negative to the opposite part, it becomes positive. Okay. All right. So you just got to stick with the exponent rules that I gave you on the other page, right? And a negative exponent just means the reciprocal. If the negative exponent is on top, where do you move it? And make the exponent.
Positive.
If the negative exponent's on the bottom, where do you move it? And make it Just the exponent part, right? Not the base, right? All right, let's take a look what we got down here. Let's rewrite these as equivalent simplified expressions. Well, let's take the top. What's getting cubed?
All of it.
The 3, so it's going to be 3 cubed times x to the 2 times 3, right? Because it's power to a power, right? All over 9x to the 4th, right? But what's 3 cubed? 3, right, 3 times 3 is 9, times 3 is 27,
That phone's getting a little big.
right?
Just wrote the number down.
So we have 27x to the what? 6th, 2 times 3, over 9x to the 4th. Well, let's reduce 27 over 9.
3.
Okay? So it'll be 3x to the 6 minus 4, right? So the answer is what? 3x squared, that simplifies to. Okay?
Probably didn't even need to do any of that.
Well, I'm doing a lot of it like breaking out, like where I show you multiply, right? Eventually you'll be able to skip some of these tedious steps here, right? Okay. So why don't you guys try part B here on your own?
Okay, I have a question.
Yeah.
2, you'd like me to subtract
Wait,
it?
what's 2, where, to what?
Okay, it's 5x squared, right?
Uh-huh.
Dividing, you have to subtract like the one, the x on the
Not right now. First of all, you got to get them all out of the parentheses, right? Like I did here. I didn't do any of that subtracting, but I got them all. I got it like this first, and then I can do that, what you said. Okay? So kind of use this one as a model maybe on that one. So everything in here is going to get squared. Guys, what is 5 squared? 25. What is x squared squared? X to the, what do you do with those exponents?
8.
Power to a power, you multiply them, so it's x to the 4th. Y to the what? 6. You multiply those x, right? Power to a power, you multiply them, yes?
Yeah.
Okay. Now let's do the bottom. 10 squared is what? 100. X to the
Oh,
what?
I did that wrong.
X to the what?
Y. 1.
That's a 1 and that's a 1. X to the squared. Go ahead.
Squared. Y squared.
Y squared. Now you're never gonna, like these exponents you'll never add, right? Because they're different bases, the x and y, right?
Yeah.
Okay. Now let's simplify. 25 over 100, what does that reduce to? 1 over 4, right? So it's going to be over 4. I don't need the 1 up there. Okay, x to the 4th over x squared is what? What's 4 minus 2? X squared. Y to the 6th divided by y squared times y to the
3. Y
4.
Oh.
Not y 4, y to the 4th, right?
My answer was a little like that.
Lot. All right. You just follow the rules, like one step at a time there, okay? I don't think so.
You said 110.
Yeah, you did say that. Okay. Let's go to this last one here. I don't want to do this thing that they,
Alex computer.
yeah, I don't want to mess with that because they do it a weird way. No, we're just going to simplify this thing. So let's just take this 2x squared and see if we end up getting that. That's what we want to get, right? So it'll be, just write down your 2x, the whole thing squared, over 4x, that whole thing squared. So do the top, do the bottom. Cute. Cute. Did I write it wrong? Oh, I did. I thought you said it was cute.
Yeah, the same. I thought you were calling Tammy. I was like, Tammy, I think you need. I think you need a little bit more rest. I think you need to go touch some grass.
Can I write it for you? Don't.
got 1/4 back.
Yeah.
Because it reduces.
You're reducing it before you take care of the squaring. You're not following order of operations. Remember, PEMDAS is always in play, right? Parentheses, exponents, then multiplication, division, right?
Reducing is not.
Hey, Serenity, what'd you get on the top? So when you looked at it and you said, what is 2 squared, what'd you say?
4.
Okay. And then 4 what? What is that letter?
Oh, 8. X.
X what?
X is X squared.
Squared. Okay. I'll go on the bottom. Four to the third power is the same as 4 times 3.
12x.
It's 4 times 4 times 4.
I don't know, like, you got
Oh.
X squared minus.
16 times 4.
It's a number. It's a double-digit number.
Just count lines. Or use your calculator. Kim,
It's 16.
I got 4. X squared minus X cubed over 16.
okay, but we're supposed to be trying to get that.
I don't get
That's what I got.
Well, you're close. You got another, right? You're, I think you were close.
I got that.
So this 4 to the third is 64. X to the third power, right? But now let's reduce the 4 over 64.
What
Yeah.
is
So it's over 16, right? And this would be x to the 2 minus 3, right? By the dividing rule. What was 2 minus 3?
-1?
So it's x to the -1 over 16. But what do you want to do with that negative exponent?
On the bottom.
Bring it to the bottom and make it what? So what will be left on top is just 1 over 16 x to the first. You don't have to write the 1.
Yeah, I got that.
Yeah? Okay. Start to get the hang. We have to get
That makes some sense.
what makes no sense.
All of it.
Which part? 2 minus 3.
No, I mean how you just read the -1 and 2.
Algebra.
You flip it, so then it's.
No, okay, well, all right. I'll put it in here. The 4 over, this is worth doing, right? So the 4 over 16, you guys told me it reduces to 64, 1 over, right? So that's still 1 over, right? 16, because that's what you told me. I just didn't put the 1 in there, but maybe it's better for clarity. So if I take this thing here and move it to the bottom and make the exponent positive, the 1 stays up there. I just didn't write the 1 back here. Maybe that's where it confused you. You said you didn't know where the 1 came from here.
Yeah.
It came from right here. It was here all along. I just didn't write it. Yeah? Okay. All right, let's look at the region stuff there. So, take a look at this first one here. Formula. Lab technician, business function T of M equals 2 times 3 to the 2m plus 1. Let's think about what that means. Do you notice up in the exponent here, and think of our rules, right? There's certain times when we add exponents and certain times when we multiply them, right?
Yes.
Is there something up here being added?
Plus 1.
Yeah? So that means that it came from doing what? Power times a power or power to a power?
Power to a power.
Yeah, come back and look, well, no, not, look back here. You see where we added the exponents? It came from doing what? Just multiplying these, right? And then down here, where we multiply the exponents, that came from power to a power. But in that problem, we have the two exponents being added, right? Right?
Yeah.
Okay. And also we have the two exponents, the 2m is multiplying, right? So it's like a combination of multiplying exponent expressions and power to a power. So kind of both of them in there. So they want to know which of these three is equivalent to that up there. So you're going to want to work around with this, right? We're almost going to kind of work it backwards from our rules, right? We're going to kind of work in reverse, yeah, maybe? Okay. Yeah, you gotta know this so well, you're working backwards. Let's do this. Let's take the 2 times 3. And I have it, yeah. 3 to the 2m plus 1. That adding of the exponents, what did that mean to do with the 3? So the 2 will be here, right? We had 3. How do we end up adding? Exponents comes from multiplying the bases, right? So times 3, right? So what would be on what would be the exponent on this first 3? 2m, right? And this one would be 3 to the what? 1, right? That's where that 2m plus 1. See, we're just working backwards, right? Okay. Well, what's 3 to the 1 equal?
3.
Okay. So 3 to the 1 is 3. What is 2? We remember you can multiply in any order, right? What's 2 times 3? So we have 6 times 3 to the 2m, don't we? Is that looking like one of the choices up there? Okay. Which one? It looks like choice 1, right? So just like, we've got that. Maybe there's another one. That 3 to the 2m. Where does that come from? Huh? How do we end up multiplying the exponents? It comes from doing what? Look back at your notes page and see where the rule said to multiply exponents. Go flip back to your notes page. Which rule told us to multiply, and you should keep this handy. Mm-hmm. So what do you think this looked like then? 3 squared in here, and then what? M on the outside, right? Because if we were, the way we've been doing, right, if we had this, we would call this 3 to the 2m, where you multiply the exponents, right? Right, so what's 3 squared then? So this is 6 times 9 to the m, right? That's that one. Choices 1 and 3. Choice 3. Okay? You just had to like work our exponent rules in reverse, that's all. You just got to know where they came from. So the next one, by the way, this word shouldn't be here. That doesn't even make, that's just cross that out. Computations word. Like on the Regents exam, on the multiple choice problem, there's a space off to the right on the page, and they have the word computations to play in spaces for somehow that word got over the problem when it got copied over. Anyway, bacteria growth. Population as a function of time equals 300 times 2 to the 4t. So it's kind of like the other one. Which one of these is equivalent to 300 times 2 to the 4t? That's not even parentheses there. It doesn't need to be, right? Now, so think about where you get multiplying exponents from, just like we did up above. And we're going backwards with our exponent rules. Still have the 300. But what about that 2 to the 4t? Where does it come from? Power to a power. So rewrite that as a power to a power. Not yet, not yet. We will. I want to see it as a power to a power. What's the power inside parentheses? So inside parentheses, you'll have 2 to the 4th to the t, right? Again, because if we work this backwards, right, if I was going to try and simplify this, this would end up being 2 to the 4t by a rule, right? So, what is 2 to the 4th power? Use your fingers, everybody. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 300 times 16 to the t. All right, choice 2. And you getting this now? I know the Regis questions just threw everything in reverse really quickly. Right, you had to work it all backwards, but have that notes page handy with the rules on it, right? So then eventually, you should get it. There's something on the homework that I want you to, like the stuff I crossed out here, like the way they were doing it. So like a number 5. Let me just give you another note here. So for the problem set, number 5, just simplify. Okay? They have you go through some process. I mean, their method of teaching it is different than I really want to do. So just simplify it, number 5. So I can have it up there. So just do what they did, write it as an equivalent but simpler expression, just like we were doing in the notes, okay? Don't worry about the product of fractions, one of which is 1 that's never been in. Okay, just simplify. Okay? All right, go ahead and start your problem set. I bet you can get it done right now. Have that rule, have those exponent properties in front of you, right? Until they get into your brain.